Right. So we have this problem where you can see an underground conical tank, okay, standing on its vertex. Now it's being filled with water at the rate of 18 pi feet cube per minute. Okay, it's being filled with water at the rate of 18 pi feet cube per minute. What does it mean? It means very simply that dV by dt is 18 pi, right? Keep the unit for now. So it's being filled with water at this rate. Okay. What other information have they given us? They've said that the tank has a height of 30 feet. So it has a height of say around 30 feet here, and it has a radius of 15 feet. Radius is 15 feet here. Okay. So say this we write as h. This is equal to 30, right? Or rather make it h equal to 30 is this height, and the radius is 15. This they have given. What are they asking us? They're asking us, so water is filling up, right? The water is slowly filling up, and that we can see is being filled up, say, at an instant, it is here, somewhere here. Right. So this is what is water. It's being filled up. Fine. So they've asked us, how fast is the water level rising when the water is 12 feet deep? How fast is the water level rising? How fast is the water level rising? Now, water level is an instantaneous thing. It is increasing by the second, by the minute, in fact, here. So, say if you take it as h, if you take that as h, right, this water level as h, we need to find out dH by dt. Okay. And we have to find out when h is at an instant, say it has reached 12 feet. So this is 12 feet. Now come back to here. We see that the volume rate is constant, right? It's 18 pi all through. All through water is flowing into this conical tank at the rate of 18 pi. That is constant. But dH by dt is not, apparently, because they've said when it's 12 feet deep, find out dH by dt. So if it is some other height, it will be different from that. So the rate will differ with height. That is what they're giving us a clue. Okay, so we'll have to find that out whether that's true or not. We'll find that out. They have not asked us to do any such investigation, but we'll try and find that out also. Now, if we say, what is the mother formula we'll require for this, connecting, say, volume with height? We know the volume of a cone is given by V equal to 1/3 pi r square h. Now, if we write this, the big R, we write this as capital R, right? This is the radius of the cone. So this is the instantaneous radius which is done here. Okay. Say this we take it as R. Right. Now the point is that we have to find a relation between dV by dt and dH by dt. Now this R has to be removed from here. Okay. That is the only exercise we've got to do. Now how do you remove R from here? Well, if you can do some You can use some geometry or you can use some trigonometry, whatever. Both will work. Suppose I draw a line from here, okay, and I find that uh, if I name this as O, if I name this as A, B, C, D. Now, if I look at the triangles here, two triangles, OAB and OCD, we find them to be similar. Similar because both of them have the same 90-degree angle. Okay, both have them this, they share this angle, corresponding angle, so they're similar. Now, if you don't understand similarity, I'll take a class for that. But it's very simple. If you have two triangles which share two equal angles, equal corresponding angles, then we can write the ratio of the sides to be equal. So we can write, you can say that R by H, or if I may write it for you, say AB by OA, for the small triangle AB by OA, okay, will be equal to for the larger triangle CD by OC. CD by OC. So if you now plug in the values, what do you have for AB? You have R. For OA, you have H. For CD, you have 15, and for OC, you have 30. Right. So you have R equal to H by 2. Got it? Now, what is the advantage here? If you name it as equation 1, say, name it as equation 2, you can replace R here by this value. Okay, so you have a new thing. You have V equal to what? 1/3 pi H by 2 whole square into H. Now you have only an equation connecting V and H. That was what we set out to do. So this pi by 12 H cube. Right. Now you differentiate it on both sides, you get dv by dt, and you can find that dh by dt depends on H also. So my question would have been that does V depend on H also? But they have given us it to be constant. So since it's constant, so we cannot take that as a variable. So you just got to differentiate this and do the rest. I'll give you some time to copy it down, and then I'll explain it again, and then we'll differentiate it this to get to the answer. We still have some work left, right? Did you get it? Get the whiff of things so far?
Yes, sir.
Okay, I'll go over it again, but first you copy it down, right?